let's see this question. Though it's a bearing, we will take bearing as a whole topic of itself, but the sine and the cosine rule we are treating require us to go and pick a bearing past question, then we see. Now this is 2008 question 14b. It reads 2 points A and B are on a bearing 040 degrees and 020 degrees respectively. From, I've underlined from to indicate that it is very, very important whenever we are working anything relating to bearing. So from a point O, so the point of origin O is the point where we are going to take the 040 and 120 from. That is our point of concentration. Now if the length OA equals 12 meters and the length OB equals 15 meters, we have to calculate with three significant figures the distance AB. Make it the distance AB. Good. So in this, when we are solving this question, what we have to do is we must first, in bearing, if we do not draw the diagram, it will be very difficult for you to get it. As I said, the bearing is a topic under the trigonometry that will be treating it separately. So when we get there, I will add one or two things. But what we are going to do now is for us to be able to get the diagram. So first, our point of origin is O. So I have O here. My due north sign indicates here. Let me extend it a little bit up. Okay, good. Then we said from O, our first movement is 040 degrees. O to A from O, so A. Let's say it is locating here. Okay, good. So what we have is the bearing is 040 degrees. And we say alternating angles are equal. So I have to elongate this a little bit. Good. So if this part is 040, automatically we will have here to be another 040. So alternating angles are equal. Good. Then we go on further and see this part is quadrant. So if here is 40, what will be left here? 50. 50 degrees here. So that the quadrant is 90 degrees. And 50, it means that the top here will also be 50 degrees. So that every quadrant becomes 90 degrees. So this is the point of A. This is the point A. So I have my A here. Good. And from the same question, it also reads, and the bearing B from the same O is 120. So O is the point of origin. So we still stand at O. Then we measure 120 degrees. 120 degrees will be somewhere here. And the distance, know that the first one, the distance is, we have it to be 12. We change the ink so that it will be more clearer. The distance is 12 meters. So we have distance 12 meters here, which is clear now. Good. So the distance is 12 meters. Then we are going to look at another bearing, which is 120. So I stand here, I'm just moving. This is the 120. So I move. The distance is going is 15 meters. My ink is giving me a headache. Okay. Just extending it with this so that the ink will be clear. Good. So this one comes here. I have to elongate this because in a natural sense, we should know that 15 meters will be longer than 12 meters so that you can fit the figures very well. So you ask yourself this question. If this part is 120 and the the quadrant is 90 degrees, what will be left? If I'm elongating it from here as 90, what will I add to 90 to get 120? You will see that I need to add 30 degrees, so there will be 30 degrees here, which is 030 degrees, so that it will be the 90 degrees. In that regard, if this place is 30, alternating here will also be 30 degrees, and here will be 60 degrees. 60 degrees. Good. The question says you are to link A and B. So here is my point B. You are supposed to find the length AB. So I will just have to create the link here. I'm creating the link here so that it will be more clear. So we have it like this. Now, unlike the previous ones we have done, in most of the bearing questions, you will see that one side of the angles will be 90 degrees, but this one, none of the angles is 90. So it means that we cannot apply the normal trigonometry, but it is either the sine or the cosine rule. So we have the angle created here. Look at the triangle AOB. The angle created within, that is the angle created here, is now 80 degrees. Is 80 degrees, or 080. Now the figure here is more than, the figure here is more than the 40, and then over here too is also less than 60, because when we say this, the whole of this part is 60, so that here becomes 30 for it to become 90. But we are not going to work angles. The only thing we have to look for is to calculate for the length AB. So we have this section to be 15 meters. So from the law, what we want is AB. So we can put our formula. And the formula reads, the length AB squared must be equals to, we're going to have OA squared plus OB squared minus twice OA OB cos theta, or I'm using cos alpha degrees. So what do I have AB? AB squared is now equals to, what do we have for OA? OA is 12. So we have 12 squared plus, we have OB, which is 15 squared, minus twice 12 times 15, cos the angle we had is 80 degrees. 80 degrees. So we point this. You just work it straight so that you get your value. So I'm going to have AB squared. 12 squared will give me what? 144. 15 squared will give me what? 225. Okay. Now this one is a product, so I prefer you work all together. So this part, you just use minus the calculator. If you want to take it one by one, so that you are showing working. So with that, you just take your calculator, then you punch 2 into bracket, 12 times 15, you close the bracket, cos 80. So that is exactly what I'm going to do. I have minus 2, or just point, because you have brought the minus, you just point 2, you open a bracket, 12 times 15, you close the bracket, you add cos 80, 80, you close the bracket, and you are going to get 62.51, maintain the answer. So you got 52.51. You have 62.513. Okay, so I add this part. I still have my AC squared. Okay, so 144 plus 225 will give me 963. So we have 3 first, that is 3, then 6, 9 minus 62.513. 62.513. So the calculator should do the work for you again. You will now point 3, 6, 9 minus 62.513. Okay, and you are going to get 306.487. So you have AC squared. Sorry, AB squared, no AC, AB squared. Thank you. AB squared to be equals to 306.487. You find the root of your answer. So AB is equal to root of 306.487. So point root on the calculator and impute 306.487. 487. What do you get? You are going to get 17.506, and you're supposed to leave your answer, said what? In 3 significant figures. First write the figure before you run to the significant figure you want. So you have AB equals to 17.506. 0677. Running to significant figure, you deal with it on non-zero degree. So I start with 1, 2. This is my third significant figure. After the 3, it is 0. So I'm going to get 17.5 meters. That is the distance AB. Good. We will now go on further to the application of the real trigonometry. Then we will come back again to bearing to complete the lesson. So thank you for now.